how many of you know about or heard about green hydrogen as a clean energy source? Let's see. So most of you, let's say, we heard about that. That's good because it's a really trending topic right now, and it seems like some people, have the misconception that green hydrogen is the ultimate and only solution when it comes to decarbonization. And today, our speakers are going to tell you why it's not the case, and actually, it's only part of the solution. So let me start with this question as an opening question. And Mr. Akram, to what extent do you think that it's realistic and feasible to look at green hydrogen as the only way to do and decarbonize economies?
Thank you, May. I definitely concur with the statement you made, that it is not the silver bullet. There's a lot of potential. We are in the nascency phase of applying it and shifting it from what it's currently being used for as hydrogen. Most of the hydrogen at the moment is being used in refining and being used in fertilizers. And the shift towards being used in transportation is really the next big thing, at least from the studies that we're seeing. And it's a lot of things need to come together in order for that shift to happen. There are estimates out there that talk about a 30% use of green hydrogen in transportation, but we need to see a lot of things happen from a regulatory aspect, from a customer aspect, and from a technology aspect, and finally from a scale aspect in order for that to happen. However, it is part of the solution. Back to your question, it is not the solution.
So just for you who don't know much about hydrogen, so hydrogen is the most abundant chemical element in the planet, on planet Earth. And it's being used currently, and it's being looked at as a pillar, or one of the pillars when it comes to decarbonization, and especially that it can be produced from clean sources or from gas. But the positive things about hydrogen has to do with the fact that it doesn't cause emissions, which is the key topic here. It comes with other negative side. The negative side of it is that it may be costly. It needs a specific infrastructure, which brings me to you, Doctor. And I want to ask you today about how we are using hydrogen in different industries, and to what extent do you think that this use in these industries will change in the years to come, and we're going to see more industry processes relying on hydrogen rather than other energy sources that are harming the environment?
Thank you very much. First, my pleasure to be here with all of you. And now that I see there are many experts in the audience, even better, because we can complement each other. I have been working on hydrogen for more than 25 years. So when hydrogen was not in fashion as now. Why? Because 25 years ago and today, going back to your question, we were already using hydrogen. So hydrogen is used essentially in three main sectors today. Refining, that's why oil and gas companies know well what hydrogen is. For fertilizers, otherwise we wouldn't be alive, so this is essential. Fertilizers are essential for taking care of the food that we eat, and also for chemicals like methanol. So this is the current use of hydrogen, and by the way, it will continue this way. But now there is a change, which is a change in paradigm when we talk about decarbonization, as you say. Now hydrogen is not only for these three sectors, but hydrogen is an energy vector that can be used to store energy that can be used later to produce energy and for other industrial sectors. And that's the difference. So we also have been working with hydrogen for transportation for many years, and this is one of the things that we're going up and down, fashion, no fashion, fashion, no fashion, depending on how much money the companies wanted to invest on the infrastructure, because that's one of the limitations. But hydrogen for the heavy transportation is clearly a solution because it's a clean fuel, as you say. Once you have the infrastructure for the heavy transportation, including maritime in some of the cases, even aviation, then this infrastructure can be used for all the other transportation as well. So there are trains already running on hydrogen in Europe, for example. So that's one possibility. But then we have the hard-to-abate sectors. Hard-to-abate sounds very bad, but it was actually a panel discussion before. Hard-to-abate sectors means industrial sectors that you cannot decarbonize just by electrifying or just by using renewable energy. You need to do something else. In these sectors, like metallurgy, we had one discussion before on aluminum, for example, cement, heavy transportation that we mentioned, hydrogen has a key role to play. First as a source of energy, but also as part of the solution of these technologies. So there is a huge promise of using hydrogen, not as the solution, as you say, but as an important part of the solution.
But Marcel, we cannot ignore the fact that hydrogen is kind of a versatile energy source. So to what extent can we rely on this fact in saying that it will execute a revolution when it comes to industrial processes?
Yeah. Well, again, also thank you for inviting me here as well. And my experience doesn't go back as long, 25 years, but it was already like 20 years ago that I was working at BP Oil, and we were having cooperation, strategic cooperation with Ford Motor Company, and we were already having hydrogen cars developed at that time. They were never commercialized at that time because we were a bit ahead of the curve, I think, then. And the market wasn't there, but it shows that the hydrogen is not new, and hydrogen has been used in its current form as grey hydrogen already many years. So I'd like to speak about clean hydrogen rather than just green hydrogen, because we have other ways of producing low carbon hydrogen, as we like to call it, where there is a low carbon footprint, and that shows the versatility perhaps of the product. You can make it in many different ways. You can make it from, effectively out of water. You say hydrogen is the most abundant element, but that's mainly in the way of water, how it is on our planet. But you can get it out of the water again if you use electricity. And if you use renewable electricity, then we call it green hydrogen. So that's a plus point. But we can also get it out of natural gas. We can split natural gas actually without emitting CO2 by using a technique called methane pyrolysis. And then we have, often it's called purple hydrogen, or a turquoise hydrogen, I have to say. And we can also make it in different ways, basically. We can also make it in the traditional way, but capture the carbon, and then we call it blue hydrogen. So there's different ways that we can create low carbon hydrogen. It's versatile because if you make it green, it has no carbon footprint. But also when you use it, I think it was already mentioned, the only product that you get when you burn it, rather than with fossil fuels, is that you only get water as a byproduct, basically. So that makes it possible to produce and to use hydrogen in a completely carbon neutral way. And there are many different places that you can use it. It's already mentioned in the industry, in the refineries. Actually, fossil fuel refineries need a lot of hydrogen for the processes, basically, to get the right products out of the refinery. That will eventually die when we don't use fossil fuels anymore, but that will still be quite a few years. Ammonia is being mentioned, is another way, but and then we talk about hydrogen is also a building block. So when you start with hydrogen, you can rebuild other fuels like synthetic fuels, methanol, or SAF was being mentioned, synthetic sustainable aviation fuels. We can even make synthetic natural gas with hydrogen as a building block. So it is basically can be used to any kind of hydrocarbon that we used to get from fossil fuels. We can in the future get from renewable hydrogen.
So what you're talking about is the different techniques that we can harvest hydrogen, and all of these techniques, of course, require an infrastructure. And the thing is, infrastructure requires billions, millions, and billions of dollars. So I want to ask you, Mr. Akram here, can we rely on the current infrastructure we have for the oil and gas industry to make this transition to hydrogen as an energy source? Does it work?
Well, I mean, and obviously my colleagues would know a lot more than I do, but the density of the molecule itself creates a bit of an issue with regards to the transport, because of the density of the molecule is so small that the current piping networks that we have, for example, in natural gas and others, will not allow you to transport hydrogen through a pipe network. You will need to create a much more robust, for the lack of a better word, network of pipes in order to transport it through that. However, there have been and there are many, many ways to transport hydrogen as an energy source, as a chemical for use in refineries, which is to transform it into something else and then bring it back to hydrogen. So ammonia is something that we've heard a lot about, and there are projects that are in place, especially in our region as well, that are deployed on that fashion. There is a bit of a chicken and an egg situation in the sense that you would need regulations, policies, incentives, customers, offtakes, financing, all to come into place with the technology scale that we would also need. I mean, it's just to give you some statistics, there are 2,000 odd projects right now on the topic of hydrogen happening around the world. 80% of them are still in the feasibility stage. And by the way, they've been in the feasibility stage for a while, because we're waiting for things like the IRA in the US to get more established in terms of the incentive schemes that they want to put forward. There is an incentive scheme, it's a 4-tier incentive scheme, but it's still quite difficult to achieve that tier. The Europeans have looked at it from a different angle. They've tried to create it from a demand angle, where they've started to stipulate certain sectors in transportation to use blended products such as SAF and others, and to use a certain amount of hydrogen usage or hydrogen-based usage for energy in their transportation space. So to your question about transportation, it's difficult. It can be done with the right economics, and it can be done with the right incentives and regulation schemes, but it needs to all come together. And by the way, we are seeing it somewhat come together, right? So massive projects like the ones happening next door in Saudi Arabia are an example of how they're happening in a very large scale, with everything falling together in place to some extent.
So one of the factors you mentioned is the financing factors. And hydrogen produced using clean energy costs 4 times the hydrogen made from natural gas. And my question to you, doctor, is how can we reduce the costs?
That's a difficult question. If I have the answer, I will be a millionaire. But I will try to. Can I, before answer that question, add something to
yes,
what
please.
Akram said? So one of the things that can help to develop the infrastructure is what the Clean Hydrogen Mission Innovation is promoting, that is called hydrogen valleys. We call them also here hydrogen oases, which is a combination of companies that will, different industrial sectors that will produce and utilize the hydrogen at the same place. So then you don't have the problems of the transportation. You don't have to invest on transportation. And this is something the UAE is also looking at, and we have to look at this more. If we generate these valleys, the cost will be reduced just by having this. The other way of reducing the cost, answering your question, will be always by doing research, innovation, and technology development. So when you do this, you can break some of the limitations on the efficiency on producing the hydrogen. So for the same amount of water or natural gas, you will produce more hydrogen with less energetic cost. So technology innovation is always part of the equation. That goes actually with something that it has been said everywhere, and we will continue saying that here, which is collaboration. So, and now as a voice from the university, not only collaboration between companies, we need collaborations between companies, the government, and academia, because our future leaders, don't forget that, are in academia right now. So if they start developing the technologies, knowing where the problems are, and finding solutions, they will help all of us to speed this up. And believe me, this is true. I see that every day. So we have to work on improving the technology. By the way, we need investment for that. We also need policies to force us to do this. But technology is always part of the solution, always.
So we mentioned as challenges when it comes to using hydrogen. One of them was cost. The second, we discussed transferring hydrogen. What other challenges, Marcel, do you look at when we talk about using hydrogen to decarbonize economies?
Well, it basically comes down to, first of all, let me say that I heard this morning, it was, I think, in the presentation of the CEO of DEWA, that by 2030 we have 57 million tons of green hydrogen or clean hydrogen. But that is still not enough to replace the current grey hydrogen. So if you want to, if climate change or combating climate change better is the goal, then we have to replace the grey hydrogen, because the grey hydrogen has an enormous carbon footprint. For every kilo of hydrogen, you produce about 10 kilos of CO2. And that creates already a couple % of the global carbon footprint. So that is something that we need to address. And then it's not just about the cost of the hydrogen itself, but what is the cost of climate change? And that is something that we need to factor in. And one of the goals is to replace the current hydrogen, grey hydrogen, with blue or green, eventually green. And so that's important to consider as well. But we need to develop a market, and the market is, you can say, well, let's use all the hydrogen that we produce to replace the grey, and then we're done. But then you don't, that is not the future scenario, because we need to create a market where hydrogen is being used as the favorite fuel rather than the current fossil fuels. And that needs technology development, for example, and then you need to look at what do you replace, and that's where demand comes from, and that's where the choice is from, let's say, a fleet operator who operates a fleet of trucks who can use hydrogen as an alternative to diesel fuel. But then it needs to be competitive for him, because he needs to run a business. That doesn't mean that the hydrogen needs to cost $1 or $1.50 for him, because you have 1 kilo of hydrogen will be the equivalent to, let's say, 4 liters of diesel, which, if you look at the price of diesel, and that is maybe in Europe 2 euros per liter, then it's 8 euros. If you make it a bit more costly because it is harmful for the environment, then maybe the hydrogen needs to cost $10 per kilo. But it needs to be $10 per kilo at the place where he can get it, where he can fill up his truck basically, and not at the place where we produce it here in the UAE or in Saudi. And you need to take the whole value chain basically into account and make sure that you can get it from A to the place where it is eventually needed at a cost competitive price.
Marcel, let me ask you, are hydrogen derivatives as important to decarbonizations as hydrogen itself?
Hydrogen derivatives are important for 2 reasons. One is to make it easier to transport. As Akram said, hydrogen has its challenges because it's so light and it's difficult to liquefy, like we liquefy natural gas, for example. So if we make a derivative, like ammonia is one of them, is a sensible one, because ammonia we need anyway. We can look at other ones. I brought an example here. This contains hydrogen. This is a Dutch technology company, a new clean tech company that produces hydrogen in a solid form. They make sodium borohydride of hydrogen, and then it becomes very easy to transport and to store. Once you ship it to the other side where you need the hydrogen, you add water and some acid, and then the hydrogen will come out basically, and then you can use hydrogen. Sorry?
And then you can have energy.
And then you have energy, because then you have hydrogen at the place where you need it. So you can leave it stored in a solid form as long as you don't need the energy, and when you need the energy, you add the water and then you have hydrogen. So you overcome the problems, the challenges that you have with storing hydrogen. There are other ways to do it. There is liquefied organic hydrogen. That is another carrier, or derivative as we call it. And there you use a kind of fuel, an oil kind of substance, which you use to bind hydrogen. And you add the hydrogen, transport it easily at low cost in existing infrastructure, like oil tankers, because they can be used for that. And then again, on the other side, you can release the hydrogen out of it. And that makes it, and there are a lot of these new technologies in development, which some of them are still at an early stage, and they need investment to be sort of piloted further and tested at scale. But they will actually help to grow the hydrogen economy.
So, in a nutshell, hydrogen derivatives can solve quite a bit of the challenges we can face with hydrogen itself, using hydrogen itself. But at the same time, I look at some estimates, and the estimates say that 90% of hydrogen plants have no buyers and no contracts so far, which raises a question about demand. To what extent we are not seeing enough demand to support these plants working at full capacity? What's the idea of having a plant spend billions of dollars, get loans from governments, grants from governments and loans from bank, and then build the factory and the plant and not having demand to support?
I guess you're asking me that
Yes.
question. So I think first of all, yes, if I was to be advising an investor into an hydrogen plant, offtake would be one of the questions that needs to be answered. So, you know, where are you going to sell it to, what contracts do you have in place, and how do you structure the agreements around that place? I also think that, back to your point about what other challenges, and I don't think it's a challenge, I think it's a curve that we need to go through, which is the cost side of the equation. Right, electrolyzers at the moment, there are many different types of electrolyzers that you can use in order to extract the hydrogen, and standardization, modularization of those electrolyzers at scale, back to Dr. Vega's point, becomes a very important element on the overall cost curve to bring it down in order to be able to provide it at a lower cost curve in whatever derivative format you are eventually selling it up on. I do think that what we have seen in the renewable energy space, and we're talking about green hydrogen, and we've seen the cost curve in the renewable energy space with PVs, etc., is helping the hydrogen case as a whole in the scenario of the green hydrogen delivery. I do want to concur. One of the important points that was raised by my peers here is that the most ideal scenario is a local scenario. It's the supply of hydrogen locally. That is the most ideal scenario. To your point about the customers and the offtakes, at the moment, the most advanced geographies around the world with respect to use of hydrogen from a demand perspective are the US, Japan, and Europe. And that does raise a question. But having said that, it is still less costly to produce it in regions such as ours. So the transportation question does need to be answered. And to me, I sound like a broken record, it is part of the overall equation that needs to be answered to answer your question around the feasibility of plants. But I do agree with you, a lot of plants, FIDs, and breaking grounds and capital deployment have been postponed as we are in the feasibility stage. And I believe feasibility translates to offtake.
Yeah, if I can add to that, with creating the local demand, is that we have to look at the whole problem of climate change and carbon footprint more holistic, because it's not only producing and shipping the fuel across, you can also put it in the product itself. Take, for example, steel or aluminium, which is being produced here in the region. If you use hydrogen to produce it rather than fossil fuels, you can make what they call green steel or green aluminium. And if you produce the product which has then a zero carbon footprint, then you have achieved the goal already as well in a different way.
So, Doctor, to this point, to what extent do you think that we're going to start to see more of the industrial products that we're used to being made using renewables, like green steel, for example? How far are we?
Well, I think we are on track. We believe in that, which is a good, important point. But I want to answer, I answered that question, but I go back to your point also. So these plants that don't have demand is because they are testing the technologies, correct? So we need to test technologies before we go to full scale. That's one, and many of these plants are at this stage. What we really need to do is to connect the demand with the production. So it makes no sense to have a hydrogen plant if you don't have customers, correct? But then if you have customers and you don't have hydrogen or low carbon hydrogen, you have another problem. So they need to grow together, hand by hand. And then going back to the steel example or the aluminum example we saw in one of the sessions today, this is a beautiful example because you have to generate the hydrogen in situ to produce the hydrogen that you will use to replace part of the carbon that you use today. So you have two applications of hydrogen there. One, you can use the hydrogen to produce your product, so you replace the carbon, you have less carbon footprint, but a lot of less carbon footprint, but you can also use the hydrogen as part of the energy that you use for the plant. So you can combine the, imagine, in a perfect, beautiful green plant, you can have renewable energy that you can store the excess of energy with hydrogen and then use this hydrogen when you don't have renewable energy to fill the plant, plus the additional hydrogen that you use for that. So there are beautiful examples going on in this direction. There is a plant in Sweden already We are working on one here with Emirates Steel. They are considering this seriously, and several other. I think these are the first examples that are like the models that proves that the technology works. Still expensive, but then once they work, the technologies always work the same way. The example that we put with renewable, with solar. Solar was very expensive. You have some help, and then the cost went down. With hydrogen will happen the same. And once you use the hydrogen, it's not only the cost of hydrogen, it's the benefits of using hydrogen, correct? And there is another thing that we don't consider, that is that this helps us to diversify the economy, because there will be new businesses around hydrogen, which is not necessarily the user of the hydrogen. You could be the one developing the electrolyzers, the one preparing the new pipelines, the other infrastructure. So there are many other ways that could help to develop a different economy. Going back, it's not only climate change, it's a new paradigm on new fuels, new energy that we are working on. So there is a combination where we have many opportunities for new businesses, new products, new technologies altogether.
So it's an updated ecosystem.
Yes, exactly.
So to this, Akram, to what extent do you think that regulation will play a big part of having to incentivize the public, the mass, into using clean energy sources? To what extent do you also rely on the collaboration between the private and public sector in this shift in decarbonization?
Yeah, I think I love that question, and we just released our global sustainability report earlier in September, and one of the key insights that came out there, and I'll come to your question, one of the key insights that came out from that report was that there has been, over the past 2 years, a very noticed shift in consumers. And let me elaborate what that means. Consumers no longer want to buy a sustainable product only, but want to live a sustainable lifestyle. And there is a nuance in that. It's not about picking up a product and looking at the carbon footprint of that product and making a decision. It is an overall thinking that your consumer, the mentality has started to shift. So the point around what needs to happen, producers of hydrogen, producers of energy need to start providing a product that tackles that consumer's need for a sustainable lifestyle as opposed to just green energy. It's part of the overall equation of that consumer. I think that's point number one. I think point number two, and I think Marcel raised this point about this is it is most economically feasible as a local product, hydrogen. However, it is a global topic. And so coordination through transparency, through real proper carbon credit systems that are transparent and are fungible and can be traded globally, like the example of green aluminum. The Chicago Mercantile Exchange is a massive place for green aluminum, and it has been provided for the world. The same kind of mentality towards this transparency needs to be brought in through the governments. Now, there are different ways of tackling it, and we already discussed how IRA are doing it, which is a little bit different than how the European RED2, I think, program is doing it at the moment. But overall, it needs to be driven by an incentivized program, as you mentioned. The incentivized programs, like with solar 15, 20 years ago, needs to come from governments in order to make sure that we do deploy a solution that tackles that consumer need towards a more sustainable lifestyle. Transparency and tradability really becomes the factor that I would think about to answer that question.
So, Dr. Lourdes, I would like to hear your thoughts on this, not only about the public-private collaboration that needs to happen, but as well on what Mr. Akram was saying about that the consumer today doesn't look at sustainability from one angle. He looks at it in broad. He wants the full theme of sustainability, not only aspects of it.
I fully agree with that. Actually, one of the benefits of being a university professor is that you see how the new generations come and what they think. And you see this change of behavior in the new generations, which I think are influencing also the older people. So the generations 20-something, the people that I have in my class, I would say my hands, but in my class right now, have this whole integrated concept of sustainability. They care about the world, by the way, and they care about the way we handle our things. And they are very serious about this. So if they grow with this mentality and this expands to all of us, the whole thing will come alone, because in the end is what the customers demand, correct? So a company will provide what the customer wants. And this is a new paradigm that we need. But it has to also be help from above. We really still need the incentives, so that if you have the combination of the customers asking for a product and someone helping you to make this product more feasible, we have the perfect equation. So yes, sustainability is not only hydrogen, it's not only energy, it's food, water, air, everything comes together.
Lifestyle.
It's a lifestyle, exactly.
So, Marcel, coming back to you, and from your technical expertise, when you look at hydrogen, what potential, what opportunities do you see in hydrogen as the world shifts globally to decarbonization?
Well, we started actually with talking about is hydrogen the one solution, and it isn't, obviously, because I think where we can electrify things, we should electrify things. But you should take into account that at the moment, of all the energy that we use in the world, about 20% is in the form of electricity, and 80% is in the form of molecules. And you can make a shift there. You can probably increase the amount of electricity to, I don't know what, 50, 60%, but you will still need a lot of molecules in the future to meet all the energy demand, basically. And that's where hydrogen can be used. Hydrogen, but also, like I said already earlier, from hydrogen you can make other products. You can make sustainable aviation fuel, you can make methanol, you can make any kind of hydrocarbon, basically. You can build back up again at a cost, but the technology is improving and there's a lot of investment in new ideas, etc., where hydrogen can be used. And that is because it takes a long time to develop that. That's why we need to invest now in those clean tech solutions, because they need time to come to full, where they can be scaled up, basically, and need to be invested in. So,
as we are in the age of AI, where artificial intelligence is disrupting different industries, it's disrupting how we live our daily lives, not only industries. To what extent, Marcel, is it gonna also have an impact on clean energy sources and on decarbonization? To what extent, from a technical perspective, do you think that we can rely on AI as a stepping stone or to support the decarbonization process globally?
Well, AI in itself will not replace the molecules, of course, but it can help to make the use more efficient and can help to develop technologies in a better way. So I see that as supportive. But you mentioned earlier that we need to build a whole ecosystem, basically, for clean energy, and that's what it is. It's a whole value chain that we need to develop with many different aspects to it. And that, if you talk about clean hydrogen, that starts already with clean water that we need to produce clean hydrogen, particularly here where water scarcity is an issue. But you can make clean water also in a sustainable way with, as we heard this morning as well, and as we have some companies. I represent a network of 42 companies, meanwhile, from the Netherlands who are involved in the hydrogen sector and play a role in every part of the value chain, and you need all of them basically to build that ecosystem, and starting with clean water and with renewable energy, and then you need people who can transport hydrogen, who can liquefy it and can deal with the cryogenics. You need temperatures of almost close to the absolute zero to make hydrogen liquid, which is high-tech business, basically. You need pipelines that can transport hydrogen. We have companies in our network who have composite pipelines rather than steel pipelines, because steel pipelines can become brittle with hydrogen and are not usable, but there's already solutions for that. And all those companies basically play a role in building that ecosystem and in making sure that it's all connected, and that's where a lot of collaboration and working together is needed to build this ecosystem.
So Akram, you just mentioned that Bain just issued in September, I think, the sustainability report. How many times did you mention AI in this report?
Well, I mean,
I cannot read any report nowadays without at least 5 or 6 times of this report mentioning AI. So how many was it for?
It's obviously an important topic. It's something that, you know, the way that I think about AI, whether it's hydrogen or not hydrogen, is that how do I deploy AI to my advantage in my corporation, right? So there are many ways to do that in the form of hydrogen technology, in the form of hydrogen scenarios that you can develop. We talk a lot about 2050 targets and 2040 targets, but as a CEO of a company, I need to understand what does 2031 look like, what does 2032 look like, and what does 23 and etc. That's what I need to understand in order to define my strategy, which is how much capital, human, financial, and economic, do I actually put in to a certain product. So AI can definitely play a role in the scenarios and the different permutations of the scenarios based on what you put in to defining what the future may look like in a staggered fashion. There's also a lot of this is, as Marcel mentioned many times, this is a very high-tech industry that does require quite a bit of permutation from an engineering perspective in order to make work. And obviously AI, as we know, plays a very big role in that. So you mentioned the report, so I'll mention the report. What the report does is that it actually talks about sustainability and talks about the importance, the still very important agenda item of sustainability on all corporates, but does, yes, mention how AI can help across that. So read the report if you want to see how more.
So, Dr. Lourdes, we mentioned earlier that there needs to be a global collaboration between different governments when it comes to decarbonization. Why is this of such significance, in your opinion?
Because the addition of 1 + 1 is not 2 in this case. So there are many synergies that can be used when you collaborate. There are different perspectives, different interests, all complementary. So you can help each other to build this much better than individually. That's why this collaboration is essential. They will come with different views, different perspectives, different interests. By the way, there is cake for all. This is a business. This energy transition business will give opportunities to anyone in any sectors. There is no competition. We need to collaborate. Alone, we cannot do it. It will take us forever.
Marcel, I would like to hear your thoughts on this global collaboration.
Yeah, that is important, like Lourdes already says, and we do that. We work close with the Netherlands government, actually, and the Netherlands is a bit of a front runner with regard to developing the hydrogen economy. A lot of investment is taking place, not just to the government, but also the infrastructure builders like the ports. We work close with Port of Rotterdam and Port of Amsterdam. They've already signed multiple MOUs with the UAE and with Saudi and with Oman to develop basically all the different scenarios that you can think of transporting clean green molecules better from here, in what derivative to choose. Is it LOHC? Is it liquefied hydrogen? Is it ammonia? And there's a lot of work there needed, because if you ship ammonia, it's not just that you get it in Rotterdam and then you can use it. Then you need to have what they call a cracker, because you need to crack the ammonia back to hydrogen if hydrogen is the product that you need. And that is technology that exists, but it has never been used at big scale, and it needs to be developed to be able to use on both sides. And therefore, governments on both sides of the supply chain need to work together to make sure that the whole supply chain kind of connects seamlessly, let's say.
So we still have 5 minutes before I have to wrap up. Mr. Akram, your final message that you would like to deliver from this panel around this topic.
I'm actually going to paraphrase what you started saying, so I'm going to steal your final words. It is an important part of the solution in this journey that we, and I might sound cheesy here, but as a human race are trying to achieve. It is one part of the solution. It does require a lot of coordination, a lot of incentives, a lot of economic feasibility and customers to make it happen, but that is something that a collective needs to solve. We strongly believe in the power of hydrogen as one of the many energy mixes that will achieve and get us to achieve what we're trying to do globally. It's a locally used product in its most economic state, but it is a global problem that we're trying to solve for, and we're now starting to see some real economic feasibility coming out of it. So it's definitely a space to watch.
Dr. Lourdes.
I will use 2 sentences. One is that hydrogen is part of the solution, so we have to work on that, because we have to believe on that, and there are opportunities for everyone. But the other one, I'm going to borrow from someone. I forgot my mobile there, so let's see if I remember, which is water will be one day an inextinguishable source of energy that together or alone or with hydrogen and oxygen will provide more heat and light that carbon is providing today. This sentence is not mine. This sentence is from Jules Verne, The Mysterious Island, 1874. So think about it, because that was already there. You know what changed? That instead of continuing working with carbon, we discovered oil. And then we also developed engines. And that's the revolution. But now we can go back to this idea, and that's what we are talking about today. So the future is here.
This is beautiful. Marcel.
What would I say? I think what we kind of said about the solution as well, that's part of the solution. I read a lot of, hydrogen went through a bit of a hype, let's say, a few years ago when the whole discussion started and everyone was enthusiastic, and now it seems to kind of be a little bit down. And people are getting sort of pessimistic. Projects are not being decided and so on, because the demand, etc., is not there. And people are some people are believing maybe don't have the trust anymore in hydrogen. But I think that's a little bit soon to come to that decision. Energy transition will take a long time. I also don't like what I often see in publications, that people see it as a bit of a competition between electricity and hydrogen, and I think you need both. I think we concluded that already here. And we should stop sort of saying, well, one is better than the other, that hydrogen is not efficient and it's too expensive. Well, if you produce it here, it's a lot cheaper than when you produce it in the Netherlands, for example. And that is kind of where we need to kind of have the global, need to use globalization basically as a way to produce it where it is cheapest, so that we can use it. The sun is free and the wind is free still, and we can use that to our advantage in a very good way with using hydrogen.
This is beautiful. Thank you so much for joining us today, and thank you for our audience as well for joining us.